So today I'm going to be picking apart a tricky variant Sudoku, and normal Sudoku rules apply, and it's a yin-yang puzzle, so each cell is either hot or cold, and hot cells and cold cells each form an orthogonally connected single region. So if you've got a hot cell here and a hot cell here, they must orthogonally connect. I suppose a nice way of saying that rule would be, given any two cells of the same colour, there exists an orthogonal path between them. That's an alternative formulation. And there's an additional constraint that a 2x2 block cannot be monochromatic, cannot be entirely hot or entirely cold. Now we've also got cages, and a cage sums, well, this cage is -10, so it has two cold cells, two cold digits in it. A cold digit counts negatively and a hot digit counts positively. So a cold 2 and a cold 8 would work. That would work. And a couple of corollaries to the yin-yang constraint. If we've got this pattern, why does that break the yin-yang constraint? This means the rest of the grid is unfillable within the yin-yang constraint. The proof is that the blues must be orthogonally connected, so however we do that. But in so doing, we cannot now connect the orange to the other orange orthogonally. And the second corollary is that it's okay to have some blues around the border and some oranges around the border, but if we were to create another region of blue, this now breaks the puzzle. Can you see why? It is because we would have to orthogonally connect blues, but now we cannot orthogonally connect oranges. Very nice. Let's start. So, as already noted, this -10 has to be two cold cells. This 17 has to be 3 hot cells. If it was only 2 hot cells, the hottest it could be is 9 and 8, which is 17. But then we've got to subtract, we've got a cold cell, which will be decrementing the value by at least 1, so 16 would be the maximum. So these are hot. So straight away I'm looking at the border corollary, the second one, and I think this -15 should be able to, can that contain 2 hot? So if it contains 2 hot cells, that's at least 1 and 2, which totals 3, which constrains these two to be -18. But 9 and 8 are the maximum they could be, so -17 is the maximum, so that's a contradiction. So at most there can be 1 hot cell in these 4. So one of these is cold. which means that all of these here must be cold, and also this one here itself must be cold, because, well, it can't be hot, because if it was hot then this would have to be hot as well. So the 2x2 monochromatic constraint puts a hot there, and a hot there. This digit we can work out. Minus 34 is massively cold, so 98765 would be minus 35 and plus 1. If those digits are lower, then this digit also has to be lower in order for the total to remain the same. So if we went 98764, then we would have to put a 0 there. If this goes down by 1, then this has to go down by 1, and the total remains the same. So that's 98765, that's 1, that's 234. Now 22. Can they all be hot? I mean, can both of these be hot? No, because of the box constraint, the 2x2 constraint. So one of them is cold. And given one cold digit, let's say we've got a cold 3. If I can show that breaks it, then the cold one must be 2. So we've got a cold 3, and we've got 4 more boxes to fill. So minus 3 and plus 2, 4, which is 6, gives plus 3. And we've got 2 more cells to make 22. That would have to be 19 total, but 17, 9 and 8 is the max. So a cold 3 doesn't work. So the cold one is 2. That's hot, therefore it's not the 2. Therefore the 2 is in that box. And let's check. I think we're going to get 8, 9 here. A cold 2, that's minus 2. So we have to get 24 from the other boxes. And 3 and 4 is 7. 7, 8, 9 makes 24. 8, 9. Hot. Eight, 9. 8, 9. This 6 box cage, 6 cage, those are cold. So even if they're just a little bit cold, 1 and 2 is the minimum. That's a minus 3, which we need a plus 9 to output 6. And if these were even 1 digit bigger, then this would have to be a 10, and so it's completely constrained. Oh, and that puts 8, 9. The first corollary, the checkerboard constraint, says this cannot be blue, otherwise we'd have blue, blue, orange, orange. So that is an orange, which makes this the blue, which makes it the 2, and that's a 3, 4, and we are away. 1, 2, 1, 2, 1, 2. Let's put them properly like pencil marks. So this negative 20 kg, if it was negative 1, negative 2, negative 8 and negative 9, that's 20. So that's what it has to be, because it has got a 1 and a 2 in it. So they not only do they have to be negative, but they also require an 8, 9 to get the total. So 8, because there's an 8 up there, 1, 2, 9, 2, 9, all cold. This box here can't be 4 blues, so this -8 must be a hot and a cold, and the only one that's going to work is -9 and +1 to give -8. So 9, -9 and +1. And 1, 9 sees 2, and 2 comes out from there. So straight away we've got 1, 9, 2, 3, 4, 8. So we've got 5, 6, 7 remaining. What can we do next? This hot has to escape in order to remain connected, as does this one. (16) without a 9 and an 8, could it contain a cold cell? Well, 2 hot cells is maximum 7, 6, 13, so the third one would also have to be hot. So these are hot. Therefore that's cold. Two by 2 monochromatic says cold. Checker pattern says cold again. Checker pattern says hot here. And we've already filled in rather a lot. This -15, it can't be all blue, because that would create a 2 by 2 blue box. So one of these is hot. But we already showed it can't contain more than one hot, so that's definitely cold. So can we, doesn't have 9 and 8, so a cold 7, 6, 5, think 6, 6, 6, 18, 7, 6, 5, 18. So we've got a -18 and a +3. That would work. Do we know which of these is the hot one though? Can we infer that somehow? Well, what about that square there? If we could show that was cold, then that would have to be hot. So can this be hot? That 1 means 2, 3, 4 is the lowest that we can have, and 2, 3, 4 makes 9. So if those are all hot, then 2, 3, 4 equals 9 is the lowest it can be, and it would need a minus 9 to get back to 0, and it can't because that's there, so we know that's cold. So now we know this is hot, and that's cold. That can't be isolated. That's cold. How about that last square there? That would be nice if we could constrain that. If we could constrain that to cold, then we have cut off our hot region, and it would have to extend down there. So I think this is where to apply focus now. Can we do this? 7, 6, 5 cold and 3 hot is, well, that's as cold as we can get it, and that requires 3. So any less cold would require less heat, less than a 3 there, and 2 and 1 are taken already. So that is indeed 7, 6, 5 and 3, which leaves a 2, 4. So the net of these two is either +2 minus 4, which is -2, or -2 plus 4, which is +2. So whichever digit is here, in order to get 0, this one has to be 2 above it or 2 below it. Is that enough to work on? Well, where does 5 go here? Can't go in a 10, because that would make 5, 5. So it's not there or there, so it's there. And I write that in because it might constrain this digit here. It's more information in the cage of the cell we're trying to figure out. So what can this be? It can't be 1, 2, 4, 8, 9, so it's 3, 5, 6, 7. So 3 would put a 1 or a 5. Can't be a 5. Can be a 1. 5 would put 3 or 7. 6 would put 4 or 8. Can't do a 4. Can't do an 8. And 7 would put 5 or 9. But it can't be a 5 and 9 is taken. So 7's not an option. Now, can we do the colour of this cell? Well, the minimum heat is 3 plus 2, which is 5, and the maximum cold is 4. So we're running on at least +1 from these 3 cells. So we require a -1 at least. We require something negative here in order to get 0. And this is massive. Look, it's giving us a hot there. Checkerboard constraint is giving us a cold cell there. We've got another checkerboard constraint giving us a hot cell there. And this region has to escape, which gives us a hot cell there. This is a magnificent puzzle. Really, it is splendid. So where can we go from here? This -4 is minus, but it's got 2 hots, just as this one, 6, was hot, but it had 2 colds. So let's try and constrain it in the same way. Minimal heat, 1 and 2, that's a +3. That would require a -7 to make -4. Any more heat and we'd need more cold to get the same resultant, but 8, 9 are taken. So it is 127. And that 1, 2, well, 2 up there gives us 1, 2, and 1, 2. 1, 2. That's putting 4, 2. That one's taking 1 out from there. Now we've got a further constraint, so I'm going to delete this and redo this box. These now have a net of -2. So if that's a 3, that has to be a 1. Does that make sense? 3, and that'll take it down to a 1. So we'd have to have a -1 to balance back to 0. And we can't, so 3 it is not. 5 would put 3. 6 would put 4, but 4 is taken, so it is 5. That is 3. Those pencil marks can go. That's no longer 5. Can we crack the 10 now? 1928 cannot. 3746 can. 3746, but 4637, we've already got a 3 in that cage. So that is 37 and 46. Four, 6, 5, 2, 3, 7 means 189, but 19 fixes 8. Seven puts 5, 6 pair. 3, 5, 6, 1, 7, 9, 2, 4, 8. 2 up there, 4, 8, and 2. Now this, I've done this puzzle before, and this is the trickiest section. It's all easy after we've negotiated this. This 13 cannot be hot, 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 because if it was, then we have to hot all the way around, and we've got a 2 by 2 of hots. So the 13 has to contain a cold digit. It can't contain more than one cold digit, because to get to 13 you need to add 2 hots, because 1 hot only goes up to 9. So it's hot, hot, cold. So if that's the cold digit, so if these two are both hots, then they're 2, 4, 8. If they're both hots, that's a maximum of 12, 4 and 8. But we require a cold, which would take us downwards rather than upwards. So one of these two is a cold digit, and this digit is hot. So what about the 2? Is the 2 hot or cold? Well, if the 2 is, what are we expecting it to be? 13. I'd say we're expecting a small cold digit. Like if we had a cold 8, then the remaining 2 digits would have to make 21, which is completely impossible. And if we had a cold 4, then the 2 hot digits would have to make 17. And there'd have to be 9 and 8. So it would have to be 4 and 8, which would put a 2 there, which it can't be. So we can't have a hot 8, we can't have a hot... Sorry, we can't have a cold 8, we can't have a cold 4. So it must be a cold 2. So if it is a cold 2, then the remaining 2 hot digits have to add up to 15, and it can't be a 4, 11, it would have to be an 8, 7. So it's 2, 8 and 7. Just going to notice that I can do that and take the 7 out of that. So it's a 2, 8, 7, putting a 4 there. And we would like to know which is the 2 and which is the 8. So it would be nice if we could, we've already got a 2 in there, if we could fix the 8 somehow, then that would resolve the ambiguity. So I'm going to leave this cluster for now and do some filling in and see if we can get ourselves an 8 in this box. So 16, can it not have a 7? 8 and 9 are taken. Could it be 6, 5, 4? That's 5, 5, 5, which is 15. Can't, so it has a 7. So that's not a 7. So we've got a 5, 6 pair, which puts the 7 there. And so 16 is 7 and 9. 1, 8, 2, 7, 3, 6 or 4, 5. So 3, 6, 5, 4, or 4, 5, 6, 3. That's 3, 4, 5, 6. Oh, but if it's 3, 6, then it would have to be the 3 in that cell and the 6 in that cell. And if it's 4, 5, it would have to be the 5 in that cell and the 4 in that cell, which doesn't help us very much at the moment. 2, 2 puts a 2 here, leaving 15. 7, 8 cannot. 6, 9 has to be 2, 6, 9. 2, 6, 9, 5, 6, 1, 9 is leaving 3, 4. So we have a 3, 4 pair there. Ah, that 3, that's a 4. 6, 5, 3, 4, 3. 4, 6, any takers? 1, 9, any takers? Nope. Still haven't got our 8, 5, 6. Is this going to help when you get cell colorings out of... if they're not in cages, then I don't see how putting in digits is not going to help us to color those squares. What are they anyway? 1, 2, 3, 4, 5, 6. 5, 6. 2, 8. We really need to know which way round they are. 5, 7. Oh, 5, 7. 5, 7 puts a 5, 7 there. Don't know if that helps. 5, 7. Oh, 5, 7 down here. Which means we must have 1, 2, 3, 4, 6, 8. That's the 8. So we've got an 8 up there and an 8 there. We've done it. We've got our 8. That's a 9. So 8 puts 2, 8. The 2 is the cold one. And the 8 is hot. Therefore, that has to be cold to connect the edge. Now, exactly one of these is hot. We can't have both of them hot, then we'd have a problem. And 3 blues puts a hot there, which puts a cold there. And that cannot be hot. Checkerboard exception. That's got to be cold. That's got to escape. Now let's look at the minus 23, which seems fearsome. So my question would be, can it contain 2 hot cells? If it contains 2 hot cells, then what are the... Maybe I should list out the possibilities, because that 7 is 5, 7. So I don't have very many left. 5, 1, 4, 3, 6, 8, 7, 2, 9. And 7, 2, 3, 9, 1, 4, 3, 6, 8. And 9, 8, 6, 7, 5, 2, 3, 1, 4. I must have made a mistake. 3, 3, 3, 6, 8 was wrong. 7, 2, 3, 9, 1, 4, 5, 6, 8. And that is 3, 1, 4. My favourite number. Okay. So one of these 2 has to be hot. We can't have both cold, otherwise we'll get a cold box. There. But if I can show there's only one hot, then I've got both these cold. And that starts to look like the orange region is not going to be able to break through this padding into this zone. And it's going to have to go round that way. And that will give all sorts of juicy blueness. That will be a blue that has to get out, etc. So that's what I'm going to try and do. So what's here? 1, 2, 7, 9, 8, 3, 4, 5, 6. I hope I'm not going to have to crunch all these numbers. Well, can we work on that? What if that is a... Can we show it's a 9? Can we show it's a cold 9? Let's suppose it's a 2. No, first let's see if we can show we've only got one hot digit here. So, minus 23, that is a minus 4, so we require a further minus 19 out of these lot. Minus 19, if 2 of them are hot, then how can we get... 2 of them are hot, they're contributing a plus 3 at least, and we can't have 1s anywhere, so it's actually more than that. So plus plus 5 actually. So we'd need minus 24 to cope with that plus 5. Minus 24 in 2 cells is absolutely impossible. So only one of these 4 can be hot, and it's one of these two, so these two are cold. Now, I don't think we even need to squish numbers here, and this is what's elegant about this puzzle, is nowhere do we need to do donkey work, i.e. exhaustive combinations, because we can see that it doesn't matter if that one's blue or that one's blue, still this orange cannot get out. How can it connect to this region over there? How is it ever going to touch the boundary? How is it ever going to touch here? It's got to go through here in order to get to these oranges. How is it going to get through? It has to go round there. And the moment it's gone round there, we know we've got orange all the way to the end. Now, this 10 cage, can it have 2 colds? It can't all be hot because that's going to violate the 2 by 2. So it's got 1 cold in it. Does it have 2 colds in it? No, because 1 hot can't be greater than 9. So it's got 1 cold in it. And that cold, if it went there, we get a hot box. If it went there, we get a hot box there. So it has to go in the middle, which puts hots there. This blue has to get out. And what have we got? This blue has to get out. These 3 blues force a hot. And this, therefore, has to be blue to connect the blues. Fantastic. We have our yin-yanged our puzzle into 2 orthogonally connected regions. And now I think it should be plain sailing. Famous last words. Really, this should be a 9, surely. Such a negative number there. So suppose it's a 2, then we've got a -4 and a negative. We've got a -6. Still require a -17. Can we twiddle a -17 out of these 3? Well, 6 and 8 is -14. And that's not -3, it's plus something. So that's not a 2. 9, 2. So that's not a 2. That's not a 9. I don't even like twiddling this. I don't think it's necessary, but whatever. Okay, so how do we cope with this? 4 and 9 is 13. -13. So we need another -10 to get -23. So we've got to twiddle these into -10. So 5 and 6, that's -11, would need a +1, which we don't have. 5 and 8 would be 13, 3, that works. And 6 and 8 would be 14. And, oh, but we can't have a 4 because we've got a 4. So it had to be 5, 8, and 3. Wonderful. I suppose, why not? Gosh, this puzzle is very resistant, isn't it? Really? So the last box here, 10. I'm probably just going to get away with putting in all the numbers here. So 198, 273, 465, 235, 891, 467, 467, 532, 891. Sorry if the numbers come out in a random order, but I just recite the ones that I've got and let my brain fill in the others, and it seems to randomize. It doesn't seem to give me back any particular ordering, but I think that's okay. So how am I going to get 10 out of these three? Well, can I get a 1 or a 2? I can't even get to 10 if I use a 1 or a 2. Even if I'm using 6, that only lifts me to 8 and then I fall back down. So 1 and 2 are just out. 6 and 7 are probably going to be out as well. Like if I max these to 6 and 9 to get 15, then six and 7 are going to get me below 10. So 6 and 7 are out. Is that more manageable? So what could it be? It could be 9 and can I not do this exactly? Oh look, we can't have a 9 because we've got a 9. Why did I even have a 9? That should be 8. 8 and 4 makes 12. Would need a -2, so that doesn't work. 8 and 5, 13. Would need a 3. Doesn't work, so it's 6. And 14 and a 4 subtracted gives 10. Phew. 6, 4. It's still holding out. This is an amazingly robust puzzle. Yikes. 6, 4, 8, 5, 8, 6, 9, 2, 6, that's 2, 6, 1, 4, 1, 3, 9, 5, 6, 4, 8, 2, 1, 3, 7, 1, 3, 7, 1, 3. Look at it, holding out right until the last square. I don't know if there's some particular craftsmanship in making the minimal solution path. I'm sure there is. Stretching the minimal solution path. Or maybe I'm just missing something. 1, 3, 4. Yeah, I have to keep chugging away. This one's given 198, 427, 36, 5. And what am I missing here? 3, 5, 4, 6, 8, 1, 2, 7, 9, 7, 2, 2, 1, 9, 1, 9, 1, 9, 1. Oh, look at that, holding out even now. 1, 3, 3, 4, 4, 1. Ay, ay, ay. 3, 4, 8. 3, 4, 1, 3, 1. What's here? 8 by that row. What's here? 5 and 4. And that puts 7, 5. My goodness. So having done this puzzle 3 times, I'm still barely faster than Simon Solve on Cracking the Cryptic. That's insane. That really is amazing. Okay, well, that was an enjoyable puzzle. I think it's really well made, well crafted. Agent, thank you for sharing your creation. Over and out.